The next property we need to explore are zero exponents. So if I were to take 3 to the 5th and have it over 3 to the 5th, we know from using our quotient of powers property that we would take, since we have this common bases, we would have 3 to the 5th minus 5, so we had to have 3 to the 0. But what does this mean? What is the value of that? So let's rewrite this. So if I have 3 to the 5th over 3 to the 5th, let's expand each of these exponents. So if I have 3 to the 5th, I have 3 times 3 times 3 times 3 times 3. And that's all going to be over the same thing. 3 times itself 5 times. Oops. Now, if I were to divide out all of the common factors in the numerator and the denominator, then I would be canceling these out. So 3 divided by 3 gives you 1, 3 divided by 3 gives you 1, 3 divided by 3 gives you 1, and you get that same thing over and over again. So 3 fifths over 3 fifths equals 1. So that means that if I have any number, non-zero number, I'm going to clarify for you, raised to the 0 power, I'm going to be equal to 1. So let's write out that definition. So a non-zero number raised to the 0 power is equal to 1. So my rule would look like if I had a raised to the 0, this is going to be equal to 1. However, this is only if a does not equal 0. So let's try an example. So let's say we are going to simplify the expression 7 to the 3rd times 7 to the 0. So let's raise 7 to the 0, raise that to the 0 power, so I have 7 to the 3rd times 1, which gives me 7 to the 3rd, which when you evaluate that, you get 343. Let's try another example. Let's say we have 1 times 10 to the 2nd plus 2 times 10 to the 1st plus 3 times 10 to the 0. So 1 times 10 to the 2nd gives me 10 to the 2nd plus, and if I have 2 times 10 to the 1st, I know 10 to the 1st is 10, so 2 times 10 gives me 20. And 3 times 10 to the 0, I know that anything raised to the 0 property or power is 1. So 10 to the 2nd is 100 plus 20, and then 3 times 1 gives me 3. So 100 plus 20 plus 3 equals 123. Let's try another one. Let's say that I have 4 to the 2nd times 4 to the 6th over 4 to the 8th. So I see that I have a common basis, so I can use my product of powers property. So in my numerator, I'm going to have 4 raised to the 2 plus 6, because my base is the same, so I'm going to add my exponents. My denominator is going to stay the same. So my numerator is going to be simplified to 4 to the 8th. I'm going to keep my denominator 4 to the 8th. So I can now use my quotient of powers property because I have 2 of the same bases. So I'm going to take my common base of 4, and I'm going to raise that to an 8 minus 8, which gives me 4 to the 0. And I know that 4 to the 0, anything raised to the 0 exponent, will equal 1. Now one final example. Let's take a to the 4th divided by a to the 0, all multiplied by a to the 3rd. So the first thing I'm going to do is I'm going to use my 0 power here. So I'm going to rewrite this as a to the 4th divided by 1 times a to the 3rd. So I'm going to simplify this because a to the fourth divided by 1 is just going to give me a to the fourth, which I'm going to multiply by a to the third. I now have common bases, so I can use my product of powers property. So that means I'm going to keep my common base and I'm going to add my exponents. So when I simplify that, I get a raised to the 4 plus 3, which is 7.